Let's now move towards the fourth and last step of the laser configuration, which is the laser focus. So the laser focus provides the functionality to detect the optimal laser focus position. And usually if the laser course focus has been performed, we have this result that gives us the laser focus sweep start. So in this case it's a -2 micrometers, -2 with respect to the camera focus, because the laser focus plane is not the same plane of the camera focus plane, so we are measuring an offset between these two planes. So when we run this procedure, it takes quite some time, which means a few minutes, because we need to first write a cross-shaped structure with the laser, and then we need to use the cantilever to read the holes that we make with the laser in this cross shape. So we see that initially we write with the laser. We should be able to see it in a second. Actually not very visible, so we're not writing probably that deep that we are able to see from the optical image. So now we move where we wrote, so around here with the laser, we move there with the tip and we read the surface. During this procedure, the focus height is changed by these F steps, and in this case we can choose the number of steps, and we can also again select the right parameters. In case we're not able to write well, we can increase the power of the laser or increase the dot exposure time, or also change the dot spacing. Also reducing the pixel size can be an option to have a better or more efficient writing. And the readout of the configuration in general is used to optimize also the tip laser offset. So in this laser focus read processing, we will have a laser read offset X and laser read offset Y, which are improved values of the initial tip laser offset estimation. So in this case we can see this 1.63 and minus 0.963 on Y. And in general, for optimal results, this cross shown in the graph has to be overlaid on the written dots. So in this case we see it's quite well and quite well located, and we see that the software identifies these holes, and which are relative to the different laser focus positions, and the best laser focus position will be corresponding to the hole with the largest depth. So we can also check manually the depth of these holes. In this case, this hole seems to be the deepest, and the same so this will be hole number 1, 2. So number 1 and 2, this hole is deepest, so the software will use 1 micrometer as the best laser focus position. And we can also confirm that with the topography that is being done with the nanophaser read functionality. Again, we can also change some read parameters in case we want to make the reading either faster or more precise. We can decrease the pixel size, for example, to have a finer, high resolution of the read. We can do this, and this, of course, we need to redo the whole procedure in case we want to see different values of the focus, ultimate focus values. So this is the final step of the laser configuration. You see we have the final laser focus position, which is 1. In case our samples do not fundamentally change and they have almost the same thickness, we can assume that the laser focus position is not going to change much. So we can also, in principle, skip the previous configuration and just put a laser focus position, which in general works well for our samples. Of course, it's always fundamental to perform the tip laser offset in order to know the location of the laser, and also have the camera autofocus to detect the tip. So this is pretty much it for the laser configuration. In the next videos we will see the advanced tools. Not really advanced, I mean, these are parts of the advanced tools, but optional tools, which are the laser dose array test, the laser power calibration, and the laser efficiency calculator, and how to use them to have a better understanding of the laser and a more effective use of the laser.